Hello my dear friends, my name is Paul and amateur radio call sign is Oscar Mike Zero Echo Tango. Welcome to my new video about the magnetic loop antenna. Today it's going to be a special Magloop antenna. I call it a wall loop antenna. The reason why is that you can see right behind me the antenna is hanged actually on the wall, or it's fixed to the wall, and I can't move this antenna, I can't rotate this antenna, and this all is just for two reasons. One reason is that I'm using this wall loop antenna for my openWSPR receiver, and you can see also the video in one of my previous reviews. Also, the second reason is that it's really good to have such kind of antenna in a workshop. It is actually indoor antenna only, and I'm using it by testing some kind of receivers or transceiver or something like that. If I'm bored, actually I can use it for transmission and try to have a QSOs. I did really. I had a QSOs on 20 meters with this wall loop antenna. Believe me or not, it's extremely small. As you can see, or maybe you will see, it's a 26 centimeters in diameter, so it's a really small antenna. Okay, so let me explain everything what you need to guide you how you can build this antenna. I will give you the size and dimensions of this antenna, and maybe you will build by yourself your own. So keep watching and let's go. Alright, so let me explain actually what parts you need to build this WALLOOP Magloop antenna. Everything what you see here I found in my drawer as a scrap parts which I don't need anymore. So this is the Belden H1000, which is solid core coaxial cable. It's very good to have a solid core in coaxial cable because your antenna keeps its shape which you made. Then we a 10 square or 10 millimeter square piece of copper wire. This is also solid copper wire, and you see the length of this wire is 165 millimeter. The length of this coaxial cable you see also here. You need 2 times of 124 millimeter long coaxial cable, which is actually 1648 millimeter or 1.64 or 1.65 meter long coaxial cable. You need actually 2 pieces of this coaxial cable. Then I used this little piece of metal I had in my drawer you will see for what I will use it in a while. And also here you can see capacitor, which is actually a random capacitor I found in my drawer. So you can also find many others on eBay or AliExpress. And actually my capacitor is 2 times 320 picofarads, which means that each gang has 320 picofarads. It's very good to have a dual gang capacitor because you can use your Magloop antenna in the split stator mode, which means that one end of the main loop you connect to one gang, and second end of the loop connect to the second gang or part of the capacitor. Actually, your main loop will be never connected directly to the rotor inside, and also it has a minimal influence on touch of this knob right there. So it's much easier to tune your next possible Magloop antenna. And also a split stutter mode is very good for a performance of the antenna and increase the efficiency of whole Magloop antenna because of missing the resistivity in a whole circuit. Alright, so this is all what I need for the electrical parts, and also you will need some piece of plastic or something like this. This is a plywood, or you can use anything which is not conductive, or it has to be a isolant. Okay, so now let me show you the antenna, how it looks like in detail, and how you can actually build this WALLOOP antenna. So here you can see my magnetic loop antenna in details. You can see all the parts on the antenna. The main loop antenna made of the Belden H1000. You can see also two turns of this antenna, and you can see also that shape of the antenna is egg-like shape. Also see here the small coupling loop antenna made of 10 mm square solid copper wire, and the feed line made of the RG58 coaxial cable. Here you can see also the little holder which I made from this little piece of metallic plate. So I just cut this plate, and I used my screwdriver to have this bend and to shape this metallic piece of the holder. I put the RG58 inside and hold it with the screw. Down there on the bottom you can see also the variable capacitor, which is directly screwed to the board. Actually, whole loop antenna is fixed by these 20 mm clips made of plastic. Here in the middle you can see a little piece of scrap of the PCB board. The coupling loop is connected as a short between the middle pin of the coaxial cable and the outer shield of coaxial cable. It's actually very simple connection between two turns of the main loop antenna. I will show you in a while. And this is how it looks like in detail. You see that the small coupling loop antenna is connected directly to the feed line, and center pin of the feed line is connected to one end of the coupling loop, and the second end is connected directly to the shield of the feed line. You see here 165 mm long is this coupling loop made of 10 mm squared copper wire. And here also you can see how it is attached right in between two turns of this main loop antenna, and it is inside this plastic holder. This is a little holder for the feed line I used, or I made from this little piece of metallic plate. I just bended this plate, or cut the plate and bended it by my screwdriver. So this is the equal diameter of my feed line. Here there are actually one hole. I need to do another hole inside and use the screw and hold or fix this feed line to the base of the antenna. And now let me overview the most important part on this antenna. As you know, I'm using a Belden H1000 coaxial cable used as a loops. So the variable capacitor right there on the bottom is also made of two sections. Every section is connected to the ends of the loop.
So the first section is connected by this flat wire which I made of copper foil to the center pin of the first loop. The second pin of the first loop is connected to the first pin of the second loop. And the second pin of the second loop is connected to the second section of this capacitor, which means that both loops are connected in serial, and we have here a split stutter mode.
And the second option how you can connect your loop antennas is the first section of tuning capacitor you connect to the center pin of the first loop. The second center pin of the first loop you connect to the first side of shield of the first loop. The second side of the shield of the first loop you connect directly to the center pin of the second loop. And the second pin or center pin of the second loop you connect to here, to the shield of the second loop. And the second side of the shield of the second loop you connect to the second section of capacitor. Yeah, I know it is a little advanced, but in this option actually you will reach a maximum capacity and maximum inductance of your antenna, and you will increase dramatically range of your antenna, especially if you are using a small capacitor. So I repeat again, the second option is a little advanced, but you will actually connect 4 loops in serial. One loop is made of center pin of the first loop. Second loop is made of the shield of the first loop. Third loop is made of the center pin or core of the second loop. And fourth loop is made of the shield of the second loop. All those loops are in a serial connection if you choose a second option. And here you can see the capacitor, which has 2 gangs or 2 sections of capacitors. One section is connected by this flat wire to the center core of the loop. And here you can see the second section, which is connected to the end of the loop connected in serial. This capacitor is fixed by the little screws there on the bottom to the plastic plate of the base of this antenna. Those flat wires I also made by myself, and it is made of this waste coaxial shield foil, which is made of bare copper, and the way how I made it I will show you now. Okay, so if you wish to make the same flat wire, you have to use this little piece of coaxial shield foil. You can use a kind of form. I use this hex key, and you have to wrap this foil around the key, remove the form, and make this wire flat. And if you think that this wire is still very wide, I would recommend to use this kind, because the wider is better. But if you think it is too wide, you can also bend it to half and use a little smaller. And now you can use it between capacitor and between the loop antenna. I tune this antenna with my left hand, and in the right hand I'm holding the microphone and I'm pushing the PTT button. So this is the way or how I actually tune the Magloop antenna. So there are actually two very important things what we have to mention with this WALLOOP Magloop antenna. This Magloop antenna is directional antenna, and we need to consider the fact that this antenna cannot be rotated because it's permanently fixed to the wall. So the first thing what we have to consider is the noise in your room, in your house. So please find with this antenna the place with the minimal noise on this place. The second thing is you have to consider the direction of the wall behind the antenna, because the direction of the wall equals with direction of the antenna receive and also transmit. So if you put your antenna to the wall, which is heading towards west and towards east, like me at this time, so you have to count that this antenna will better receive signals from the west and from the east. It will also receive signal from south and from north, but with little attenuation on it. But the directivity of this antenna is not so significant as you may think, so there is no problem also to receive signals from this direction, from south to north. If you consider to place the antenna to the north-south wall, so it is vice versa. Actually, it will receive from south and north better, and a little worse from west and east. I have connected this Magloop antenna to my HF radio, which is the Zygo X6100. This is HF transceiver, 5 watt power or 10 watt power with external power supply. So the tuning process is actually very simple, but also a little different than traditional antennas. Firstly, we have to desire a band which we want to use. Then there is a tuning knob on the tuning capacitor, and we have to tune this knob or rotate the knob until we will see the noise peak on here on the screen or the noise peak on the S-meter. If we will find the noise peak on the S-meter, we know that we are tuned to the band. So I need to rotate now the knob and look at the screen. And here you can see the noise peak. The noise peak is moving from right to the left and back from left to the right, from right to the left. So if you are willing to use this antenna for receive only, it is quite okay if you place this noise peak to the center of desired band. But if you wish to transmit with this antenna, you need to place the noise peak right on the frequency, let's say here 206. So try to put the noise peak precisely to the center, and then we have to go to AM mode or FM mode. You need to select some kind of carrier mode, and then you have to push the PTT button on your mic, and we'll see the SWR right there in the second meter. The lowest SWR means the best tune. So here you can see that the SWR is very, very high, and I'm going precisely to the frequency. It is going SWR down, 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 and I'm on 0. Okay, so this is the minimal SWR right now, and the maximum output power right there.
You see, a minimal SWR and maximum power. And this point is the radio and antenna perfectly tuned, and you can transmit on the frequency, and of course you can receive signals all across the band without any problem. So if you go QSY to another frequency, you need to retune the process or the antenna again, like a minute ago. If you wish to only receive signals, you can leave the noise peak in the middle of the band and you can tune the band across as you wish. And now, once the antenna has been tuned to the frequency, we can also check the SWR scan. This radio has a beautiful SWR scanner, and you see here how this antenna is perfectly tuned to a desired frequency. This lobe here shows us that this is the resonance frequency of the Magloop antenna. And here we can already hear some first signal on HF. And this is the slow scan television on 14230, which is a special transmission for the pictures. People are sharing their pictures via this SSTV mode. Let's find some phone signals in a single sideband modulation. And here we can see an Italian contesting station, or the special event station.
Okay, 4 Kilo Mike 59. 73 India 1 Whiskey Alpha. Oscar Hotel 2. Wedge 2 Delta Alpha 59, thank you.
And you can see also some other phone signals right there. This is the digital signal, and etc. So actually this antenna works also indoors. Of course, it will be much stronger, much better reception if you would use this antenna outdoors. If you can create a modification of this antenna for an outdoor use, you can place this antenna from outer side of the wall on your house and can receive signals and work outdoors also, but you need to find some remote control system for this antenna in this case. And this is the second reason why I built the WALLOOP antenna. I wanted to make an antenna which will be a fixed antenna here at my workshop, and I can actually see what the propagations looks like on the band, and this device has a minimum power consumption, so it can running 24 hours 7 days per week, and there is not any problem with this. Currently I'm using the WALLOOP antenna connected to this openWSPR receiver. If you wish to find more information about this little device, you can go to my latest videos, and there you can find a review for the openWSPR receiver. Very nice thing. You can see that you need just the internet cable, you need to connect the antenna and external 5-volt power supply. Everything is inside, receiver is inside, computer is inside, and also program which is running permanently after you power on the receiver. Okay, so now let me show you actually what the WSPR spots reports looks like on the map in a recent 24-hour of reception with this duo, which is the openWSPR receiver and the WALLOOP antenna. So welcome to the Weak Signal Propagation Reporter Network. If you go to the WSPR.net and you put my call sign into the filter right under the map,
and we'll choose 20-meter band, you can see something like this. These are actually the stations which have been reported by the openWSPR receiver and my WALLOOP antenna. So you can see what my antenna hanged on the wall received in 24 hours of this day. So as you see there are a couple of stations from Caribbean and many stations from Europe. I'm located right here in the middle part of Europe, and I can receive a bunch of stations from Western Europe, like Germany, United Kingdom, France, Belgium, Luxembourg, but also France and Spain right on south. Also, you can see that southern Italian station is there, and also Greece, which is completely in south of my location. Even the Israeli station is there, and from Turkey. This is completely out of my direction of the antenna, because as you remember, I told you that my wall direction is west and east. So you can see that this antenna receives much better signals from the west and maybe also from the east, but this is probably due to the missing of propagations. There is one station from Russia over here also. So east-west is the best direction for this antenna configuration. But of course you can see that there are signals from south and also from north, from Denmark right here. So if you put my cosine and 20-meter band into the filter here in the WSPR.net, you can see that because this is running 24 hours and 7 days per week. Okay, and now the final and I think the most important question is on what band can we work actually with this WALLOOP antenna. So let me tune this radio to 10 meters and let me show you the noise peak on 10 meters, and we'll see if this antenna tunes on 10 meters. So here we can see the noise peak, which is on 10-meter band, 28.400. And let me tune the SWR here. Yeah, we can tune the antenna also on 10 meters with its minimal SWR right here. And SWR plot. This is how it looks like on 10 meters. You see that it's much wider than on 20 meters before. Now let me check 12-meter band. And here is the noise peak. And let me check the SWR. I can reach the SWR with 1.1 as well. And now the SWR scan. Next band will be 15 meters. And here we have the noise peak. Let me see the SWR. Okay, we can also get the perfect SWR here on 15 meters. And let's see the SWR graph. Yeah, the antenna should be narrower and narrower with the lowest frequencies. Next band 17 meters. And here we go. SWR check.
Also we have SWR 1.1 and SWR graph. Yeah, this looks also very nice. But you see that the bandwidth is narrower already. This is 20 meter band, and let me find the noise peak on 20. It is here. And the SWR check. And a perfect SWR. An SWR graph. Don't worry, those peaks, this is actually some kind of bug of the radio by the measurement. And this is 30 meters. Looking for a noise peak, and it is here. And the SWR check. Alright, this is not ideal as before already. As you see that the SWR is maybe 1.5. Is slightly higher than before, but I'm almost on the edge of my capacitor, so I suppose that I will be not able to tune 7 meter band, but before I will check the SWR graph. This is SWR graph on 30 meters. You see how narrow the band is right now on 30 meters. Okay, and I'm on 7 megahertz, which is 40 meter band, and I'm trying to find a noise peak, but I can't actually. So I cannot work on 7 meters with this antenna size and dimensions and also location. In conclusion, actually this antenna works from 30 meters up to 10 meters on all those frequencies. If you wish to enlarge this frequency coverage, you have to use a second option of connection to main loops, as we talked before. Well, so this is actually all for today. So those of you who are still watching this video, I would like to thank you very much for watching, and all possible information what I can get from this antenna project you will find down in the video description. So thank you very much guys for watching. I wish you good luck with this 1 hour antenna project, and I hope to catch you again in my next video. 73.